Hello again. We are continuing our discussion of limits by talking about how to find asymptotes of functions. So let's begin. We're looking at horizontal and other asymptotes. So whenever you have two expressions that are being divided, chances are there will be at least one asymptote. And you can figure out when that will and when that won't happen, depending on what your denominator is. So finding the vertical asymptotes is the easy part. You set the denominator equal to 0 and you solve it. But what about the other ones? Well, in order to find other asymptotes like horizontal asymptotes or slant asymptotes or worse, we need to do synthetic division. Okay, so let's say I needed to find the asymptotes of y equals 3x squared minus 7x minus 9 all over x minus 1. Well, obviously the vertical asymptote is x equals 1 because that's the x that would set the denominator equal to 0. Now, for the horizontal or slant or worse, I'm going to do synthetic division. And remember, what that means is that x minus 1 gets converted to a 1 inside that little L shape over there. And then the coefficients of the top will follow 3 for the 3x squared, negative 7 for the negative 7x, and negative 9 for the constant. And so I go ahead and I do my synthetic division. I copy down the 3 below the line, multiply 3 times 1 and I get 3. Add the 3 to the negative 7 and get negative 4. That negative 4 gets multiplied by the 1 on the outside and becomes negative 4. The negative 9 plus negative 4 is then negative 13. So that's my answer, but what does my answer actually mean? It means that 3x squared minus 7x minus 9 divided by x minus 1 is actually equal to 3x minus 4 plus negative 13 over x minus 1. So as I'm looking to the very, very left and very, very right of this function, as the x values go to infinity, that remainder becomes less and less significant. So the y values are going to approach the linear function 3x minus 4. All right, so that's what that looks like. There's the graph. I actually graphed it, and you can see the vertical asymptote at x equals 1, and you can also see the slant asymptote that has a slope of 3 and a y-intercept of negative 4. So it's a linear or slant asymptote. Okay, so there's the function, there's the vertical asymptote, and there's the slant asymptote right there. All right, here's a worse example. Remember I said slant asymptote or worse. Here's an example of how it could be worse. So let's say I want to find the asymptotes of y equals x cubed plus 5x squared plus 6x minus 9 all over x plus 1. Okay, again, the vertical asymptote you can find by setting the denominator equal to 0 and solving for x. In this case, the vertical asymptote is x equals negative 1. And then I do synthetic division, putting a negative 1 for the x plus 1 in that little L shape, and then following that with the coefficients of what's on top, 1 for the x cubed, 5 for the 5x squared, 6 for the 6x, and negative 9 for the constant. So you copy the 1, multiply 1 by the negative 1 that's outside, and you get negative 1, and you add to get 4. 4 times negative 1 is negative 4. Add that to the 6, and you get 2. 2 times negative 1 is negative 2. Add that to the negative 9, and you get negative 11. So that's my answer, but what does it mean? It means that when I actually divide that fraction out, I get x squared plus 4x plus 2 plus negative 11 over x plus 1. All right, so as x's approach plus or minus infinity, that fraction at the end, that remainder, gets less and less significant. So the y values actually approach x squared plus 4x plus 2. So there's the graph right there. The solid graph is the actual function. The vertical dotted line is the vertical asymptote. And that dotted parabola is my other asymptote. And yes, that is a parabolic asymptote. You can have parabolic asymptotes. You can have cubic ones. Any kind of asymptote that you can imagine you can have. So that is finding asymptotes of functions. And if you have any questions, please let me know, and I will see you tomorrow.